here reporting live at the scene of the parabola investigation. I'm here with Mayfield renowned Agent Y. Agent Y, can you tell us anything about the situation?
Well, we haven't come to any conclusions yet, but at the moment, I can tell you that parabolas are everywhere.
I was speaking with your coworker, Agent X, recently this morning, and she said that a parabola is the curve formed by a set of points in a plane that are equally distant from both a given line and a given point. Is this correct?
That is exactly correct. I've just been informed that parabolas are taking over the world.
Vertex form transformations. To review, the equation for vertex form is y equals a bracket x minus h bracket to the power of 2 plus k. For the first example, the equation is y equals x squared. So for this equation, the vertex is 0, 0, and the graph opens up because it is positive. To graph this equation, you start by plotting the vertex, which in this case is 0, 0. Then, because the equation is y equals x squared, the first point would be to the right 1 and up 1, because 1 to the power of 1 is 1. Then for the next point, you would go to the right 2, and 2 to the power of 2 is 4, so you would go up 4. You would continue doing this until you run out of room on your graph. So the next one would be over 3, 3 to the power of 2 is 9, so you would move up 9, and over 4, 4 to the power of 2 is 16, so you would go up 16. Then the next step would be to mirror it on the other side. The second equation is y equals 2 bracket x plus 4 bracket squared minus 8. The vertex of this equation is negative 4 and negative 8 with a vertical stretch of 2. The reason that h is positive in this equation is because vertex form is y equals x minus h squared plus k. And in our second equation, h is being added to x rather than subtracted, and this is because a negative and a negative equals a positive. To graph this equation, you start by plotting the vertex, which is negative 4 to negative 8. Then, same as before, you move over 1, but instead of moving up only 1, because 1 to the power of 1 is 1, you move up 2, because 1 to the power of 1 is 1, but it has to be multiplied by 2 because of the vertical stretch. So you would move over 1 and up 2. Then for the next point, you would do the same thing. So over 2, 2 to the power of 2 is 4. 4 times 2 is 8, so you would move up 8. And again, 3. 3 to the power of 2 is 9, and 9 times 2 is 18, so you would move up 18, and continue the graph until you run out of space. The third equation is y equals negative 1 over 2 x minus 3 squared plus 6. The vertex for this equation is 3, 6, with a vertical compression of negative 1 over 2. To graph this equation, you start by plotting the vertex, which is 3, 6. Then again, same as before, you move over 1, and 1 to the power of 1 is 1, but this time you have to multiply that number by 0.5, making your plot here. Keep in mind that because the equation is y equals negative 1 over 2 bracket x minus 3 bracket squared plus 6, it will open down. For the next point, you will do the same thing. So over 2, 2 to the power of 2 is 4, times 0.5 is 2. So you would move to here. And you continue this until you run out of space on your graph and mirror it on the other side. Vertex form transformations, part 2. Finding x-intercept given a function in vertex form. Remember that when finding the x-intercept given a function in vertex form, y is always 0. For my example, I will be using the equation y equals x minus 5 squared minus 1. To answer this equation, we already know that y is equal to 0, so you plug that into the equation and the equation becomes 0 equals x minus 5 squared minus 1. Now to solve this equation, first you move the 1 over to the other side of the equal sign, so now it becomes a positive. So now you have 0 plus 1 equals x minus 5 squared. Now in order to take x minus 5 out of the brackets, you have to make the equation 1 positive or negative square rooted equals x minus 5. So now you can move the 5 to the other side of the equal sign, making the equation 5 plus or minus 1 equals x. So first you would do x equals 5 plus 1, so x equals 6, and then you would do x equals 5 minus 1, so x equals 4. And that is how you would find the x-intercept given a function in vertex form. This concludes my video. Thank you for watching.